Okay, examples for operations on radical expressions. So start off by defining like radicals. If the index and the radicands are the same, right? So in other words, both square roots or both cubed roots or both fourth roots or both fifth roots are the same index, and radicand, the thing under the radical sign, must be the same. So, amazingly enough, the cube root of 16x to the fourth and the cube root of 54x to the fourth can be written as like radicals. And so what we're going to do is just the process we went through. So if I have the cube root of 16x to the fourth, then we can write that as the cube root of. So now I'm looking for perfect cubes, right? So what's the largest perfect cube that goes into 16? 8. And what's the largest perfect cube that goes into x to the fourth? X cubed. So we go 8x cubed. Now we need 16, so then it's times 2. And we need x to the fourth, so then times 2x. Which becomes the cube, that's a little big, the cube root of 8x cubed times the cube root of 2x, which becomes 2x cube root 2x. Okay. Now you can go there in one step if you want. And I've just written that a little poorly. You've got to watch where your 3. My 3 in that last writing looked like it was almost 2x cubed. So. Okay, now we do the same deal with 54. X to the fourth, right? So we write it out as 27x cubed, right? That has a cube root. And then 2x, because that's what's left. We need to have a 54. Which then allows us to split the, let's do that right. So cube root of 27x cubed times the cube root of 2x. And the cube root of 27x cubed is 3x. Okay, so we have like radicals, right? Because this and this are the same. Okay, so with like radicals, we could add these, right? We've got 2x times the cube root of 2x, and I could go plus 3x times the cube root of 2x and get 5 of them, right? It'd be 5x cube root of 2x. Okay, so we do some operations with like radicals. All right, so those are like radicals. Classic questions. Classic. These are classics. Without the use of a calculator and using the fact that the square root of 2 is about 1.4, find the perimeter of the square if the area of the square is 32 square centimeters. Okay. So, I'm going to start with a square. This again, why only this class? I'm going to start with a square whose area is 32 square centimeters, right? I'm just waiting for this to disappear. Like, maybe if I copy them to my desktop and just open them off of there. I don't know. Anyways, right, so we know that this area is 32 square centimeters, and we know it's a square, so this side is x, then this side is x. Okay, square.
Our number 1 is.
Yeah, I wondered about that, right? Like I'm seeing something different here too.
That's our number 2.
That's your number 2. And is your number 2 your number 3?
Yeah.
And do we have a number 3 that's a number 1? Yeah. All right, so there's. Okay, hold that. Oh God, now it's going to move the page. Okay, so actually this is number 2. Oh, this is 3.
He does get here.
Always be up there? It's just, yeah, I don't know why. All right, so this will be number 2, and this will be number 3, and that's all going to disappear anyway.
It's loading now.
Do it. Do it. Do it. Oh my god.
Is this too?
Okay, this will be 2, this will be 3. Okay, so number 1, which we'll do down here. Okay, what do we got? Hypotenuse of isosceles triangle is 18 centimeters. Given that root 2 is approximately equal to 1.4, determine the lengths of the other 2 sides. Okay, so let's draw a diagram. So an isosceles triangle has 2 equal sides. Okay, now it says the hypotenuse of an isosceles right triangle. So hypotenuse of isosceles right triangle. Okay, so that's a right angle. These 2 sides are the same, and this is 18. Okay, how do we relate the sides of a right triangle? A squared plus b squared equals c squared. So in this case, x squared plus x squared is equal to 18 squared. Okay, now remember, we're not using a calculator. So, how many x squareds do we have? 2 of them. So 2x squared is equal to 18 squared.
What's the little dot above the equal sign?
Little dot above the equal sign means approximately equal to. So x squared then is equal to 18 squared over 2. So what's x equal to? The square root of 18. So x is the square root of this thing. Okay, now we know the way radicals work, so x is equal to root 18 squared over root 2. What's the square root of 18 squared? 18. Okay, and we're given that root 2 is about 1.4, so we want to take 18 divided by 1.4, right? That's going to be our centimeters, right? That'll be the length of the other 2 sides. So 18 divided by root 1. All right, now see if we can move back up. Now these calculators using the fact that blah, blah, blah. Okay, what's the formula for the area of a square? Length times width. Well, side times side. Side squared, right? So that means we know that x squared is equal to 32. So what's x? Square root of 32. But what's the square root of 32? When you... No. It's 4 root 2. Right? So it's going to be 4 times 1.4. But it didn't want that. It wanted the perimeter. So how do we get the perimeter? Multiply it by 4, right? Because there's 4x. So P is equal to 4x, which is equal to 4 times 1.4, which is 16 times 1.4. Okay. Without the use of a calculator and using the fact that root 5 is about equal to 2.3, find the length of the base of a triangle if its area is root 320 and its height is 4 centimeters. Okay. So I got this triangle, right? And for the length of the base, so we want the length of the base if its area is root 320 and its height is 4. So what's the formula for the area of a triangle? 1/2 base times height. Okay, we know the area, right, is root 320, and that's equal to 1/2 base, and we know the height is 4. Okay, so 1/2 of 4 is 2. So we're going to divide both sides by 2, so say b is equal to the square root of 320 over 2. But what's the square root of 320? So what's the largest square that goes into 320? It's going to be, well, 4 goes into it. So if 4 goes in, then we should try 16. Now 16 goes into it, but if 16 goes in, then we should try 64. And 64 goes into it 5 times. So it's going to be 8 root 5 over 2, which is 4 root 5, or 4 times 2.3. Okay, so the base, and that will be in centimeters, right? Be about 4 times 2.3, so about 9.2, right? 16 times 1.4 would be about 22.4, so on. The bottom one, yeah, dividing is a little harder than multiplying. Okay, so let's go forward a page and wait a little while. Yep. I don't know what it is. Okay, addition and subtraction of radical expressions. Note, just as like terms in polynomials can be added and subtracted, right? So if you've got an x squared y, you can add another x squared y to it, right? You can have 5x squared y minus 7x squared y. You combine like terms. So we can do the same thing with radicals. Like radicals can be added and subtracted. Often what we have to do is convert an entire radical to a mixed radical so that we can see that these are in fact like radicals. Really? Well, we knew that was going to happen. Well, you do the first one. So what? Yeah, so really all we're worried about here is I got 4 minus 1 is 3, minus 5 is negative 2, and then what? Well, root 3. Right? So it's just like 4x minus 5x, right? They're not x's, they're root 3's. Could be apples, could be oranges. Okay, this is equal to 4 root 2 plus, what's root 8? 2 root 2 minus, what's root 32? 4 root 2, what's the answer? Okay, well we got 4 of them here and we're subtracting 4 of them there. Okay, so I'm going to go more to doing that now. I'm not going to break it out. Like yesterday was the very detailed, and today it's sort of the, yeah, that's just whatever. Okay, if you have problems with that, again, feel free to spend more time working them out, right? It's more important that you are correct than that you are fast. There's no points for speed, right, in this, right? Okay, 2 cube root 4. Minus 5. Okay, cube root of 108. Now, here's the deal. If they're going to add or subtract, then I need to have a cube root 4, right? Because that's what would make it a like term. So I want to take 108 and divide it by 4, which is 27, which has a cube root, which is 3. So this is 3 times cube root 4. So we get 2 cube root 4 minus 15 cube root 4 to be negative 13 cube root 4. Okay, now just want to scroll down and see if it's on the next page, which it is. Which means we're now going to have to wait, of course. All right, so all we're doing is taking this, changing it to from an entire radical to a mixed radical. This is 8x square root x minus 7x square root x. There is a restriction here though, right? Since there's an x under the radical sign, that x must be positive or 0. So it's greater than or equal to 0. Okay, and what do we end up with? X root x. Okay. Nope. We've got 8x minus 7x is 1x root x. Okay, 4 cube root of x to the 4th plus the cube root of x to the 7th minus the cube root of 27x to the 4th. Now, if they are all like radicals, and I think maybe they will be, right? I think they're all going to end up with a cube root of x underneath. Okay, then we can add or subtract them. This happens to be a perfect cube, so I'll be able to get the 27 out of there, so that's good. If I can't, if I have a 3 cube root x and I have 3 cube root 2x, they're not like terms, right? Remember, they need the exact same radicand. Okay, so this is 4x cube root x. Just clean that up a bit. Cube root x plus x squared cube root x. Do you want more detail? You okay with that, or you want us to do more? Okay, we'll do more. For the sake of them, what wasn't here yesterday, I might be looking up here. Oh, where is this coming from? Okay, so 4 cube root. So the idea in simplifying is to see if there are any perfect cubes under there, right? So with variables, you just write the largest power that's divisible by 3, and then what's left. So with variables, largest power, so x to the 7th, you want the largest power that's a multiple of 3, which is going to be x to the 6th. And 27 does have a cube root, x to the 4th, so we write that as x cubed times x. Okay, and I'm not going to break it out into cube root of this times cube root of that, right? I'm not going too much. So we got the 4. The cube root of x cubed is x, and then we have left the cube root of x. Plus the cube root of x squared is the cube root of x is x squared, and then we're left with cube root x minus, and we've got 3x, and we're left with cube root x. Okay, so the 4x and the minus, or 4x cube root x, right? So these guys, that's an x, that's an x. These are like terms, right? Because I could do 4x minus 3x. And I've got an x squared cube root x. I can't add, I could just add or subtract. It just becomes an expression that's added or subtracted, right? So it's going to be 4x minus 3x, which is x cube root x plus x squared cube root x. Okay, that's the answer for that one. X cube root x plus x squared cube root x. Okay, we are now back to square roots. So 2/3, that stays. Square root of 9 is 3. So this will be 3x root x minus 1/2. Square root of 128. There is no square root of 128, right? But 6. Oh, what's yours?
49.
Yeah, I'm kind of wondering, because otherwise they're not. I'm just looking at it going, well, these aren't like radicals, right? Because I'm going to have 8, and under here I'm going to have a 2.
So yeah, ours is 49, and then x is greater than or equal to 0.
Yeah. Okay, so 2 things. One, it's a square root, so there has to be restriction on the variable, right? That the x, because we're cubing the x value, so it can't be negative. So we got 1/2, then this will be 7x root x. Okay, now am I going too fast in just writing 9x cubed as 3x root x? Do you want to see more detail? Okay, do you want to see more detail? Do you want a line in between?
Yeah.
Yeah? Okay.
That'd be good.
So let me see if I can just move this down.
Oh.
Nope. Okay. We'll move that out of the way. Okay, so 2/3. So what we want to do is take whatever's under the radical sign, in this case 9x cubed, and split it up so that it's a perfect square, right? Something that has a square root, which is 9x squared, and then an x, minus 1/2, the perfect square, 49x squared, and then the x. So then we can split that out as the root of 9x squared root x, and the root of 49x squared root x. So these are the things that have square roots. Okay, so then the next line would be, so this will be 3x. So the square root of 9x squared is 3x. And we've got a root x. Minus 1/2, the square root of 49x squared is 7x. And then we've got a root x. So 3's cancel there, we get 2x root x minus 2/7 x root x. Okay, these are now like terms, right? Didn't start out that way because of the error on the page there, but they're like terms in the sense that it's actually more than just the root x's are the same. Yes, the root x's are the same, but also the front has variable and an x.
Wouldn't it be 7/2?
Sure, if you like.
Is that?
No, that's actually correct.
Okay.
Yeah, you are right. I was wrong. I will admit my mistakes when I make them, because otherwise I'd spend my life in denial. No, I never did that. Okay, so then we need, if we're going to add these, we need a common denominator, which is going to be 2. So this is going to become 4/2 x root x minus 7/2 x root x. So what's our final answer? Negative 3/2 x root x.
Can't we not have that? Because
No, restriction is just you gotta have x has to be greater than or equal to 0. This could be negative, it doesn't matter. I'm not doing, the negative's not under the square root sign.
But then that makes the other x negative, doesn't it?
No? It makes the whole thing negative.
Okay.
Okay, so here's what we've said. X must be positive. Okay, so order of operations says, what do? You do exponents first. Well, this is an exponent of 1/2, right? So you take your number, which is positive, stick it under here, you do its square root. You then multiply it by the same number. You then multiply that by negative 3/2. What that says is this answer will always, this expression will always evaluate to a negative, right? Since x is always positive, and multiplied by negative. Yeah, says your final answer will be negative. Okay, dare we move on? Yes, of course, but will it take forever? Yes, it will.
We're dividing.
Multiply, is this the next one?
Yeah.
Okay, good. Just make sure, nothing seems to be on track or working. Okay, multiplying radical expressions. All right, all you have to do is multiply, right? So you don't have to do any simplifying first, although you could if you wanted. So, here's what we'll do. We'll do this first one a couple of different ways, just to sort of show you. So what we can do is this, right? I can go 48 times 8. Okay, so I'm going to take the numbers, multiply them together, get 32. And I could say it's the root of 3 times 3 times 27.
Wait. Oh.
Okay, so 3 times 3 is 9. 9 times 27 is 243. Well, the largest perfect square that goes into 243 is 81. So go 81 times 3, which is 32. Root 81 root 3, which is 32 times 9 root 3. And 32 times 9 is 270, and 18 is 288 root 3. Now, here's why you didn't want to do it that way. Right? So if you look at it instead, right? So, this is fools rush in, right? In other words, saying, hey, just do it, just multiply it. Wow, look, there it is, right? And you get the answer, and that is the correct answer, right? So there's nothing wrong with this. It's just sort of like, there's a better way. So here's a better way. You look at this and you say, hey, what's root 3 times root 3? 3. Good. That's the thinking I want, right? So instead of saying root 3 times root 3 is root 9. No. Well, yeah. And then root 9 is 3. But just say root 3 times root 3 is 3. If I'm squaring a square root, I just get the number. So I can look at this and just say, look, this is 4 times 8 times 3. Right? So really, this is 4 times 8 times 3. And root 27 is 3 root 3. So we got 4 times 8 times 3 times 3 times root 3. And 4 times 8 times 3 times 3 is 288 root 3. So you can do it in one line or like 6 or 8 lines, right? You do a line where, hey, I got to worry about simplifying a root 243, right? Instead of saying, hey, wait, 4 times 8 is 4 times 8. Root 3 times root 3 is 3. So that gives me 4 times 8 times 3. And root 27 is 3 root 3, right? I can simplify that. This one doesn't simplify, right? Root 6, root 10, I can't do anything with them. So this one we really do have to just multiply out. So this is 3 times 4 times root 6 times root 10. Don't write that down, right? But that's what's happening, right? Multiplication is commutative, right? And it doesn't matter what order you multiply in. So 3 root 6 times 4 root 10 is the same as 3 times root 10 times 4 times root 6. It's the same as 3 times 4 times root 6 times root 10, right? So we're going to say, all right, let's just put it in order that works for us. And you don't need to write that. Just think 3 times 4 is 12. And 6 times 10 is 60, right? Now, here's the thing though, right? 60 has a perfect square that goes into it. What's the perfect square? 4. So this is 12, and 60 becomes 4 times 15, which becomes 12 root 4 root 15, which becomes 12 times 2 root 15, which becomes 24 root 15. Okay, you can go from here to here. Okay, that's okay. 12 root 60, you go to 24 root 15. I'm as happy, right? But that's just showing it, right? That's the full meal detail. That's everything that could possibly be shown. You don't need to show that, right? You could just say 4 goes into that, blah, blah, blah. Okay, cube root 4, cube root 2. Nothing I can do to simplify. It's not like root 27, right? That was 3 root 3. So this, just multiply. 2 times 5 is 10 times the cube root of 8, which is 10 times, which is 20. Okay, keep going. What do we got? 3 more pages, about 20 more minutes then, by the time we wait for the thing to catch up to it. Wow, didn't even draw anything. Okay, when this circle moves over there, then it will be time. So, doing math is like playing chess, and I would back up one board and show you, but we've learned not to do that now. So, in that first one on the other page, we just rushed in and multiplied it all out, got this root 243 that we had to deal with, right? So, look ahead a little bit. Say, what have I got here? I got a cube root 16x, and I got a cube root 2x squared. When I multiply the x by the x squared, I'm going to get an x cubed. Okay, and that's good, because that will come out then, right? Now, I can write 16. It's got a perfect cube, right? So we could simplify this. So we could say, okay, the cube that goes into that is 8, and the cube root of 8 is 16, right? So, how much detail do we need? Well, you know what? Here, we can just do this. It's the cube root of 32x cubed. Okay, because we don't lose much by doing that. It's still an 8 that's going to go into it. If you want, you could have written this as 16 times 2x cubed. Okay, but it doesn't matter. So it's going to be the cube root of 8x cubed times 4, which is the cube root of 8x cubed, because that has a cube root, times the cube root of 4, So that's 2x cube root 4. Okay, so there's not a whole lot to be gained one way or the other, right? It's not like getting 243. That's a pretty big number. 32, small enough. 8, that's the one that goes into it. Okay, we could have written this guy here as 2 cube root 2x, right? And then got the 4 under there and the x cubed. Okay, so there's just multiple ways to approach it. I don't think any one is really that much better than another, right? Like it doesn't cost a lot of time. Okay, we're going to use the F word, which is what? Foil. Foil. I threw that out just because remember we're recording this and it's a family show. So first, 5 times 6. Okay, so you're foiling, right? You are multiplying two binomials. You're going to get how many products? 4. Good. Did I do this? I mean, you can't say the correct answer. Okay, 4. So we've got 5 times 6 is 30. 5 times negative 2 root 2 is negative 10 root 2. 3 root 2 times 6 is plus 18 root 2. So this is one of the few times where I might actually write out the 4 terms, right? Just because when there's radicals involved, I don't like to keep, doing it in my head. It's sort of like, maybe, But if you think of the root 2 as an x, then you just look at it and you go, okay, I got 30 minus 10x plus 18x, right? It'll be plus 8x, but it's not an x, it's a root 2. And then what's 3 root 2 times negative 2 root 2?
6 root 2.
Negative 6 times 2. Right? So two things we don't want to do, right? We don't want to go negative 6 root 4. Right? Because we're saying, oh, it's root 2 times 2. So it's negative 6 times 2. Right? Because root 2 times root 2 is 2. Okay, so we've got 30 plus 8 root 2 minus 12, which is 18 plus 8 root 2. Right? And that's it. It's done. We leave it. Don't try and factor it, right? Okay, so you do the first line of the next one, right? So in other words, you should be writing out 4 products here. Okay, so just do the FOIL on it. Okay, just write it out with the radicals. Yeah, if it's root 28, just write root 28, right? If it's like root 14, just write root 14. Write out the 4 products, okay? Don't try and collect them in your head or anything else. Just write out the 4 products. Okay, and then I will too, and then. Okay, fit. Okay, so I got 4 root 14 minus 20 root 28 plus 3 root 7 minus 15 root 14. Okay, is that what you have? Good. I did not make any mistakes, intentional or unintentional, or you made the exact same mistakes. Okay, so, got any like terms there? So we got the 4 root 14 and minus 15 root 14, okay? Now, can we do anything with root 14? No, there's no perfect squares that go into it, right? Okay. So we can go negative 11 root 14 minus 20. Now, what's root 28? So 4 times 7. So root 28 is 2 root 7, right? So I can turn the root 28 into a 2 root 7, okay? Plus 3 root 7, right? That's this 3 root 7. So now these guys are going to be like terms, right? 2 more steps. So I've got negative 11 root 14 minus 40 root 7 plus 3 root 7. Negative 11 root 14 minus 37 root 7. Okay, That's your final answer. Okay, what do we got? 2 more things, 10 more minutes. Thing's gonna go. Okay, so expected.
Just half.
Yeah.
Nice.
See where it lands.
Yeah. That's just
Okay.
extending it.
So, you know, with radicals and squaring, I don't have any big problem if you do this, right? Now you should also do this. So your order of operation should be, I'm going to square that radical. So it's 3 root 2 times, okay, so what's root 5 times root 5? 5. Minus root 10. Minus plus. Okay, so it's 3 root 2, and we have 7 minus 2 root 10. So 3 root 2 times 7 is 21 root 2. Then what? Minus 6 root 20, right? But root 20 is 4 root 5. Or 2 root 5. So root 20, 20 is 4 times 5.
Yeah.
So it's root 4 root 5 or 2 root 5. Yeah, so this is 21 root 2 minus 6 times 2 root 5, or 21 root 2 minus 12 root 5.
Where's the other end of the bracket? On the second line. Oh, never mind, I see it. Found it. I got it. Where am I?
Why do I have a bracket there? Oh yeah, 2 root 5. Okay. Now, let's see if I can just select all of that.
I'm not gonna be able to read any of this. I could read it
I
now.
want to change the size of it, but I don't know how to change the size of it. Yeah. I don't know what to do with it.
My earphones.
Clone, cut, copy, drag, paste, select all, reset page, clearing, delete, view, dual page, display, format, tools, eraser, orange, dang it. I don't know. Should be some way to select that all and shrink it, right? Because now I got to do the next one. That's fine. Okay, we'll just do this one. All right, so you're gonna multiply this out, right? Actually, I'm just gonna erase this. Doesn't need to be there. Okay, it's gone. But it was there, and you have it. Oh, go watch the video. Okay, so 2 things, right? There's a variable under the x, under the root. It is a square root. Therefore, x must be greater than or equal to 0. So we're just gonna use FOIL. 5 root x times root 2 is what? 5 root 2x minus 30x, right? Root x times root x is x. Plus 2 minus 6 root 2x.
No.
Okay, so what do we got? We've got negative 1. So the only thing we have that's positive is the 2. So let's go 2 minus
Yeah.
1, actually, sorry, minus 1, so I don't need a 1, minus root 2x minus 30x. Okay. Yes, they're in Vancouver.
Hopefully no people get beat up again.
Hopefully.
Last game was fun.
Okay, so there we go. 2 minus root 2x minus 30x, right?
He's crazy. He's usually like.
Okay. Last one, right? This is just straight distributive law, right? Multiplying the first term. So how many terms am I going to get when I've done multiplying? 2. Okay, 8 times 9 is 72. 2x times 4x squared is 8x cubed. Minus 8 times 6 is? Okay, does yours have a cube root on here? Yeah? I don't know. Does the second expression?
That's on the inside. It's a cube root.
Oh, on the outside, yeah. But we have like 100.
100.
Yeah.
100 what?
We got 100 x.
It's negative 6.
Okay, so what's this? Minus 6 cube root.
100 x to the 5.
Okay. All right. Well, it's still 48 though. And we've got the cube root of 200x to the 6th then. Yeah, it's kind of weird. Cube root, the thing doesn't have a. Okay, so 72. So the cube root of 8x cubed is what? 2x. So this is 72 times 2x minus 48. Now, okay, 200. Is there a cube that goes into 200? 8. 8 times 25, right? Okay, so there won't be anything bigger than 8 with cube roots, right? 64 doesn't go in. Okay, so how much detail do we want? Cube root. Okay, so we got 8x to the 6, right? These are the things that have a cube root times 25. Okay, so we got 144x minus 48 times. Is it okay if I just write 2x squared?
Yeah, that's what.
Cube root 25. Okay, so 144x minus 96x squared, cube root 25. All right, so I'll let that sink in, although I should just go to the next page. It's going to take, so write it down quick, let me know. Then you can sit and stare at it for a while we wait for the next page to properly load.
The next one's that triangle.
Yeah, next one's that triangle. So that's the last one we're doing today.
Just patched it.
Okay, so when some diagram shown below, the area of the square is 32 square centimeters, right? So a square, we'll call the side lengths x. And we know that the area is going to be x squared. And we want the perimeter of the isosceles triangle as an exact value. So let's, because the triangle's all shady, let's pull the triangle out. It's a shady triangle. Yeah, I don't trust it either, but. Okay, here's the triangle. So in this triangle, we know that this is x. What's this? This is also x. So then what's this? 1/2 of x. So what's this? Okay.
Where did that I knew that.
So the length of the side of the isosceles triangle, right? And they're both the same, right? So I mean, this side is the same as this side, okay? Because it's isosceles. So our perimeter is just like 2 of these and then 1 of these. Okay, so pulling this out, the diagram out, we say, okay, look, this is x, but the height is x. Okay, we get an area, but that's the area of the square. Okay, wait, so the area of the square is 32, so we know that, what does this lead to? That x squared is equal to 32. Okay, all right, so let's plug in, right? This length that we want here, I don't know, what are we going to call it, like L or something, or Y? Let's call it Y maybe. Why not? So y is equal to the square root of x squared plus 1/2, well, let's just call that x over 2, plus x over 2 squared. Okay, so what do we got? We got x squared plus x squared over 4, yeah? So how many x squareds is that? Yeah, 5/4, right?
Yeah.
Like 4x squared plus x squared over. For the common denominator of 4, that's an x squared is going to be 4x squared over 4, right? Okay, but that can be split up, right? Root 5x squared over 2. Okay, square root of 4 is 2. Well, let's write it as root 4. Root 4. Okay, so y is equal to root 5 times 32 over 2. Where'd 32 come from? X squared is 32, right? They told us the area was 32. What's the area? The area, though, is x squared. So, and I just happen to have an x squared. That's why I didn't bother, hey, let's not bother pulling that out and going x root whatever, right? Because I know what x squared is. Okay, so what's 5 times 32? Oh, wait a sec. No, root 32 has 16 goes into that, right? So this will be the root of 5. Well, no, let's do the 16 first. So 16 times 5 times 2 over 2. So that's going to be 4 root 10 over 2, or 2 root 10. Okay, look, done, finished, right? Answer 2 root 10.
That was
Yeah, except that's not it yet, because it asks for the perimeter.
I was a loser.
Okay, so keep going. So perimeter
Oh, I'm out of.
is 2y plus x, which is 2 times 2 root 10. What's x? Yeah, x is root 32, right? So now we actually need x. So at some point, I guess we might want to go back here and just write x is equal to 4 root 2. Okay, plus 4 root 2. So we get 4 root 10 plus 4 root 2 centimeters. Right? Yeah, because it's square centimeters. Okay, so that's your final little answer thing there. Okay, so tomorrow I'll try copying this onto whatever.